How are you? Here we are going to discuss the conversion of galvanometer into a voltmeter, an instrument used to measure the potential differences and EMFs. Now, an ideal voltmeter is of infinite resistance, and if you convert a galvanometer into a voltmeter, galvanometer is having low resistance, and if I take a galvanometer G with a resistance Rg, then if I want to use this one for measuring a voltage V, I will be connecting a large resistance in series with the galvanometer. So just by connecting a high resistance in series with the galvanometer, together this becomes a voltmeter. Let us see how it is. Now, if I want to measure a maximum voltage of V, suppose, then the source will be sending a current through this one, and that current will be flowing through the galvanometer also. Then, if I want to measure the maximum voltage, that is V, then the current that must be flowing through this must not be greater than Ig. Because galvanometer can allow a maximum possible current without spoiling the galvanometer, and that current is denoted by Ig, or we call galvanometer current. So if I want to measure a voltage V, the maximum, then the current that must be flowing through the circuit must be Ig. Then, as this current Ig flow through this one, I can write the equation here as V equal to Ig into R, that is the drop across this one, plus Ig into Rg, that is the drop across the galvanometer. This is nothing but a series combination of resistance we have seen. So the voltage that is supplied here will be getting divided into two according to the resistances in series. And therefore, I can get the equation from this one as R equal to V by Ig whole minus Rg. Now this is the equation you can use to convert the galvanometer into a voltmeter for measuring a maximum voltage V. Now let us see the calculation of this R. I calculated R and I connected over here. Now let's see how this galvanometer is getting calibrated into a voltmeter. It's very easy that suppose the galvanometer scale that you all know, the scale will be 0 in the middle, and on either side the scale will be there. So the deflection may go left or right, and the needle will be like this. Now suppose V is the voltage to be measured, the maximum, and I calculated the resistance and connected over here. Then when I connect V there, I will be getting the deflection here. Maximum deflection possible. Now let us consider V to be measured is equal to 10 volts. Suppose. So when I connect 10 volt, I will be getting the maximum deflection over here, and this I can tell it as 10 volt. Okay. Then, if I connect 5 volt over here, means V equal to 5 volt the next time, for the same arrangement I am making the voltage to be 5 volt. For that 5 volt, the deflection will be falling exactly half of the ratio. So this I can take as 5 volt. So just like this, the reading from here to here, this scale is getting calibrated automatically between 0 and 10 volt. This is how the conversion or the working of the voltmeter is coming. Okay? Clear? Yes. So you are just connecting a high resistance in series to get it converted into voltmeter. So how it is working as a voltmeter we understood. So this converted voltmeter will be having a resistance. The resistance of the voltmeter will be equal to the resistance connected plus the galvanometer resistance. This is the resistance of the voltmeter so obtained. Alright. Next thing we want to consider is that can we adjust the range of the voltmeter? Can we increase the range or decrease the range? Yes. See, when the resistance is coming in series here, you can vary the resistance to the high value and also to the low value. So, just by increasing the resistance R, you can see the range of the voltage to be measured is increasing. Okay? So, if we reduce the resistance, you can reduce the range also, but there is a problem. You can reduce the range, but keep in mind that this is the value of Ig is there. This Ig is a limited value. Then, when you reduce the resistance to a low value, and if the current in the circuit is greater than Ig, then there is a problem. The galvanometer will be spoiled. So you can reduce the range by reducing the resistance, keeping in mind the current Ig should be considered. Okay? So here you can increase or decrease the range of the voltmeter accordingly. Alright? This is a very important part of magnetic effect of electric current. So please be careful with the theory part.